Here we have a limit. If we plug in 1, natural log of 1 is 0, and then 1 minus 1 is 0. So we have to figure out a way to solve this limit. It's not approaching infinity, so we can't divide by the biggest x. And there's no factoring we can do to cancel out the problem on the bottom where we're getting 1 minus 1 is 0. So we have to figure out another way to do the problem. So then we go to L'Hopital's rule and we figure out, can we use that? In order to use that, we need to either get 0 over 0 or infinity over infinity. So when I take limit of the top, I end up getting 0. And when I take limit of the bottom, I end up getting 0. So because the limit of the top and the bottom are 0, I'm getting 0 over 0, which would then tell me that I can use L'Hopital's rule. So to use it, now we would take the derivative of the top and the bottom. So we're going to do limit of the derivative. So the derivative of natural log x is 1 over x divided by limit of the derivative of the bottom, which is just 1. And so here we get 1 divided by 1. And here the limit of 1 is 1. So the answer is 1. And we got an answer. Example 2, if I plug in infinity, think about your E graph. If we approach infinity, E approaches infinity. And then here, infinity squared is infinity. So we're getting infinity over infinity. So what we just said was the limit for the top function is infinity, and the limit for the bottom function is infinity, which means we can use L'Hopital's rule. So we're going to do limit of the derivative of the top. Derivative of e to the x is e to the x, and then the limit of the derivative of the bottom. Derivative of x squared is 2x. And so here we get infinity again. And here we get infinity again. So we still don't have an answer. So we're going to use L'Hopital again because we have infinity over infinity. So we have derivative of the top is still going to be e to the x. And derivative of the bottom is now going to be 2. So here we're going to have e to the infinity is infinity. The limit of 2 is 2. Infinity divided by 2 is infinity. So that would be our answer.